Hello everyone, today we are going to start how to balance a chemical equation from chapter 1 of General Science of class 10. So without wasting any more time, let's get started. First of all, the balancing of chemical equation is predominantly based on one particular theorem that you have studied in class 9. So what is that theorem? The theorem is that mass is neither created nor destroyed. That means in a chemical reaction, when reactants combine to form a product, the number of reactants and the number of products should be same. You cannot have more number of reactants and less number of products, or less number of reactants and more number of products. It isn't possible because mass cannot be created nor it can be destroyed. So based upon this very fundamental theorem of general science and chemistry, we are going to study this concept today of how to balance a chemical equation. Now we will be seeing in many of the reactions that you have seen in the previous classes or in this book as well in class 10 that reactions are given and some numbers are written in front of them. What do these numbers signify? These numbers signify that how many molecules of each chemical compound are present in that chemical reaction. So how do we know what will be the number, how to calculate that number? That is what we are going to study in this video today. So without wasting time, let's move on to our first chemical equation. So here is our first equation of the day. Here we have C3H8 plus O2 gives CO2 plus H2O. So how do we begin? How do we begin balancing this chemical equation? First of all, let's look at the first atom we have, that is carbon. Now we have two parts. This is our reactant part and this is our product part, right? So let us concentrate on the reactant part and see how many carbons are there. First atom, carbon, okay? First we'll look at carbon. There are 3 atoms of carbon. Now in the reactant side there is no more carbon. So here we have 3 carbon atoms. On the right hand side, how many carbon atoms do we have? We have only 1 carbon atom. So here we have carbon, we have 3, and on the reactant side, and on the product side we have only 1 carbon atom. That means we need to balance them. So in order to have 3 carbon atoms, we can write 3 here, right? So 3 carbon atoms on the right side, 3 carbon atoms on the left side. Done. We have solved it for carbon. Now let us move on to the next one. What do we have? We have hydrogen here. Hydrogen is 8. Here how many hydrogens are there? We have 2 hydrogens. They are not balanced. So how to balance them? Here we already have a larger number. So let us balance it there. ठीक है ना, यहाँ पे 2 हाइड्रोजन है, इसको हमें ज्यादा करना है, हम इसको 8 बनाते हैं क्योंकि ये ऑलरेडी 8 बन चुका है ना? तो what do we do here? We can write 4 here because 4 into 2 gives us 8. Now if we again balance, we will see 8 hydrogen atoms here and 4 2s are 8 hydrogen atoms on the right hand side as well. So reactant and product hydrogen is balanced. Now let us move into oxygen. Here we have only 2 oxygen atoms. Here we have 3 2s are 6 oxygen atoms, right? Because this 3 is common for the whole compound. Okay, this 3 will account for both carbon and oxygen. So 3 2s are 6 oxygen atoms, and here we have 4 into 1. Here we have nothing, means there is only 1 oxygen atom. So 4 1s are 4. So 4 here and 6 here. 6 plus 4, 10. Total 10 oxygen atoms are here. On the left hand side we have only 2. So obviously we will increase this one. And what is the multiple of 2 5s are 10, right? So here we have, let us again check overall. Carbon, we have 3 on the reactant side. On the product side also we have 3. Hydrogen, on the reactant side we have 8. On the product side also 4 2s are 8. And finally oxygen, on the reactant side we have 5 2s are 10. And on the product side also we have 4 1s are, 3 2s are 6 and 4 1s are 4. So 6 plus 4 equals 10. So all are balanced now, and that's how we have a balanced chemical equation. Please keep this in mind that just like in a mathematical equation, if the LHS and RHS are not the same, in that case that mathematical equation is incorrect. You cannot get marks for writing an equation where LHS and RHS are not the same. In the same way, in a chemical reaction, if the LHS and the RHS, that is the reactants and the products, are not equal in number, then your reaction is wrong. So if you write a chemical equation without balancing it, the teacher has every authority, every right to cut the whole reaction. So if I am in that situation as a teacher, I will obviously cut the whole question. The whole answer. Because anything which is not balanced in chemistry is not correct. So please make sure that you balance every chemical equation that you write. So this is one example we have done. Let us look at some of other examples so that it becomes more clear to us. Okay, so here we have 3 more equations. Let us try to balance them. Okay, so first one is very simple. So here we have only a single sodium, here also we have a single sodium, so sodium is balanced. Now for chlorine, we have 2 chlorine here, but we have only 1 chlorine here, so we have to increase this one, so we will write 2 here. Once we write 2, chlorine becomes balanced. Yes, here we have 2, here also we have 1 2 the 2, but as we write 2 here, sodium gets affected by this. Now sodium becomes 2. As sodium has become 2, I must balance it here also, right? So now we have 2 sodium here, 2 sodium here, 2 chlorine here, and 2 chlorine here. So LHS is equal to RHS, hence the equation is balanced. Another thing to note here is that you should not balance anything by writing the number that we are putting. Don't write it in the suffix of any number. This becomes wrong. Why? Because if I try to write 2 here while balancing chlorine, if I write 2 here, then NaCl2 is not sodium chloride anymore. You have changed the whole compound. We cannot change the compound. What we can do is we can change the number of that compound. So if I write H2O and I try to balance it by writing H2O2, then H2O is water and H2O2 is hydrogen peroxide. So if I want to balance H2O by increasing the number of oxygen, if I write this is wrong. What I should do is H2O and I should write 2 in front. Okay, that's how you balance. Don't write any number while trying to balance. Don't write any number in the suffix, because that will make the whole concept, whole idea of the reaction wrong. Okay, so we will only write the numbers before on the prefix, right? Okay, let's move on to the next one, question number 2. Again, we are trying to get our reactants and products of the same number, conservation of mass. Okay, so here we have lead, Pb. Pb is 1 on the left side, Pb is 1 on the right side. So that is solved. Let's move on to our next one, OH. Now you see we have a bracket here, that is hydroxide, and the hydroxide has come how many times? 4 times. So we can do a lot of things, right? We can separately count oxygen and hydrogen, or we can count it together. To make it easy, let's count it together, because here also we have OH and in this position also we have OH. So let us try and make it easy for us. Here we have 4 hydroxide, here we have only 1 hydroxide. So what we can do, let us try to balance this. We will write 4 here. If I write 4 here, then what happens? It becomes O and H both become 4. Here also O and H both are 4. So 4 4 done. Let us move on to copper, Cu2. Here we have Cu but 4. So now we need to balance copper also. Here we have 4, here we have 2. What we can do, we can write 2 here. Now copper is also balanced. 2 2s are 4 and here also 4. Now we are moving to oxygen. Let's see how many oxygen we have. We will count the total. This, see, OH and OH are done. Let's not count this O now. Only count this O and this O. How many oxygen are there? 2 oxygen. How many oxygen are there? 2 oxygen. If you want, you can count everything separately also. Let us see if we count separately what happens. Lead we have 1, lead we have 1. Oxygen we have 4 and we have 2. 2 and 4 give us 6 oxygen. Here we have 2 and here we have 4. 2 and 4 again give us 6 oxygen. Then moving on to copper. We have 4 copper here and we have 4 copper here also. Done. We have balanced our second equation. Moving on to number 3 and the final one of the day. Here we have calcium first. So calcium is 1. Here we see calcium 3. So of course what we will do, we will write 3 here. Done. So calcium is balanced at the first stage. Now we are moving to carbon. See, we have carbon here. How many carbon are there? We have 1 into 3. 3 carbon. Here we don't have any carbon. How many carbon here? Only 1 carbon. See, carbon is only 1. So we need to balance it. Since we have 3 carbon here, we will write 3 here as well. So what do we get? 3 ones are 3 carbon. 3 carbon on the left side, 3 carbon on the right side. Next we have oxygen. How many oxygen? 3 into 3. 3 3s are 9 oxygen. And here we have 4 oxygen, right? I think we should do something else. Let me put it into perspective. Just like here we have done OH, hydroxide. Here we have phosphate. See, PO4 twice. Here also we have PO4. So let's try to get that first, because that will help us. If we try to take in clusters, if you balance the equations in clusters first, then it becomes easier for you to balance the final setup at the end. Okay, so let us just try to focus on the PO4, phosphate first. So phosphate we have 2 here, right? Here we have only 1. So we can balance it by writing 2 here. Simple, the whole phosphate is now getting balanced. Now let us look into the next one, hydrogen. How many hydrogen do we have? Hydrogen we have 6. Here hydrogen we have 6, already balanced. So no need to poke on that. So now let us overall check what we have done. Calcium 3, carbon 3, right? Oxygen 9 and oxygen 8. So 9 here and 2 4s are 8 here. 8 and 9 make 17, 1 7. Here oxygen, 4 2s are 8 and 3 3s are 9. See again, 8 and 9, 17. So we have matched oxygen on both sides by just focusing on PO4. See what is the benefit? If I had done it separately, it would have taken me more amount of time. I will not try to spend too much amount of time on a particular equation. So do it in clusters. The more you do it in clusters, the easier it will become for you. So we have oxygen is 17, oxygen 17 here. Moving on to phosphorus, we have 2 phosphorus here and we have 2 phosphorus here also. Simple, done. And finally hydrogen, we have 6 here, hydrogen we have 6 here as well. So these 3 equations are solved and they have been properly balanced. Now what I want you to do is open Google, search balancing chemical equations or balanced chemical equations. You will find many worksheets. Try to solve them by yourself, because until and unless you don't solve extra questions, many are there in the book, and in the book everything is already solved. So first of all, go for the exercise. Of course teachers will help you out in your tuitions as well. Go for the exercise, solve the exercise questions in schools, wherever you are taking classes. They will help you out with solving them. I have given you 4 examples which are not in the book. These are from outside the book. I have taught you how to do it. Now I want you to do it. If you have confusion, you can ask in the comment any particular equation that you have that you can't solve, you are not able to solve, put it down in the comment. I will solve it for you. I'll help you solve it for you. Okay, so don't be shy. If you are not able to do it, just put it out in the comment. You will be having other viewers who can help you out. I'll be there to help you out. We can bring it together as a community. Okay, so I hope you understand, and in the next video we're going to cover the second part of the chapter 1, that is the different types of chemical reactions. So until then, take care and cheers.